To exercise 2. Exercise 2.2 concentrates on the zeros of a polynomial. We have already studied what a zero polynomial is. To find out the zeros of the polynomial, consider any polynomial, say p of x. Then the zero of the polynomial p of x is nothing but a number c, such that if you substitute the value of c in the entire polynomial in the variables, then we get p of c is equal to 0. P of c becomes a zero polynomial if you replace the variable with the zeros of the polynomial. How do we derive the zeros of the polynomial? Just equate the polynomial to 0 and find the value of x, the variable in the polynomial. The value of x is either the root of the polynomial or the 0 of the polynomial. Let's look into a quick glance of the types of polynomial and what could be the zeros of each of the various types. The first one is a non-zero constant polynomial. What is a non-zero constant polynomial? It is just that any constant values like 2 or 1000 or minus 10,000, whatever, without any variables, with only a constant value, excluding the value 0. So, if you consider a polynomial, say minus 5, it is rewritten as minus 5 to the x to the power of 0. So, any value if you substitute in the value of x, say 1 or whatever value the value of x can take, say 10,000, anything raised to the power of 0 gives rise to 1. So, this particular polynomial minus 5 times 1 becomes minus 5. It can never give a 0 value. So, there are no zeros. The answer to this question is there are no zeros for a non-zero constant polynomial. Now, consider the scenario of a zero polynomial. In this case, it is written as every real number. Why? What is a zero polynomial? P of x is equal to 0 is a zero polynomial. 0 is derived as 0 times x or 0 times x squared or 0 times x cubed, whatever. But the constant or the coefficient is always 0, or the constant value is 0 for a zero polynomial, in which case whatever value the value of x can take, it always give rise to the value 0, in which case the every real number can be substituted in the variable x. Whatever be the value you substitute in the value of x, the resultant will always be equal to 0. So, for a zero polynomial, it is the entire set of real numbers that can act as the zeros of the polynomial. Now, the next scenario is the linear polynomial. Linear polynomial, what do we mean by that? The degree is always 1. Ax plus b is equal to 1. The value could always be equal to minus b by a. Whatever be the value of b, whatever be the value of a, just substitute that, and this gives this minus b by a gives the value of the zeros of a linear polynomial. For any other polynomial, it can have either 1 0, any number as a 0 of the polynomial, or it can have any number of numbers which can act as the zeros of the polynomial. Let's look into some facts on the zeros of the polynomial. A zero of a polynomial need not be 0. It could be any number. And 0 could by itself be a zero of a polynomial. We can look into different scenarios where each one becomes true. Every linear polynomial has one and only 0. We have already discussed ax plus b is equal to 0 is a linear equation. Then the only one and only 0 of the polynomial is minus b by a. A polynomial can have more than one 0. This also we have already discussed. We are looking into the problems given under the exercise 2.2. Find the value of the polynomial 5x minus 4x squared plus 3 at different values they have given. You just have to replace whichever value is given for the particular variable of the polynomial onto the polynomial and find its value. So, All the three sums are like that. The first one gives value of 3, second one is minus 6, third one is minus 3. The second sum, find P of 0, P of 1 and P of 2 for each of the following polynomials. The first sum and the second sum, there is not much difference as far as the concept is. They have explicitly given the value of the variable in sum number 1. Here, P of 0 is nothing but the variable in the polynomial takes the value 0. So, the first polynomial is P of y is y squared minus y plus 1. How it behaves when the variable takes the value of 0, 1 and 2 is what the question demands. So, you get the answer as it is mentioned. Same as for question number 2. Just replace the value of 0 in the value of t. What is the variable for this particular? It's a polynomial in a single variable we are dealing with. So just replace the numbers onto the polynomial and get the answers accordingly. The same rule holds good for these two sums as well. Sum number 3, verify whether the following are zeros of the polynomial indicated against them. So what is the step? Just replace the given value into the polynomial. Find out if it results in 0. Only if it results in the value 0, the given number is a 0 of the polynomial. If it doesn't result in 0, then you will say it is not a 0 of the polynomial. So you can look into the different sums that are given. Sum number 2, 5x minus pi is a polynomial. You have to replace the value of x with the value 4 by 5. So P of 4 by 5 becomes 4 minus pi. It is not resulting in 0. So the given number, how do you give the answer? You should say the given number P 4 by 5 is not a 0 of the given polynomial 5x minus pi. So all the other sums are zeros of the polynomial, meaning the given variables, if you replace into the polynomial, it will give rise to a value of 0. This sum where the polynomial is 3x minus 1, where x is equal to minus 1 by root 3 and 2 by root 3. Let's look into this particular problem. The value of minus 1 by root 3 happens to be a 0 of the polynomial. Why? If you replace minus 1 by 3 onto the value of the variable as given in the polynomial, it will give rise to the value 0. Whereas the value 2 by 3, if you replace onto the variable x in the given polynomial, it will not be equal to 0. So 2 by 3 is not a 0 of the polynomial. Sum number 8, it's a specific case where it is not, the given number is not a 0 of the polynomial. Sum number 4, find the 0 of the polynomial in each of the following cases. So, in sum number 3, we just replaced the given value in the polynomial to find out if it is a 0 or not. Now, we need to find the 0 of the polynomial in sum number 4. So, how do we go about? Just equate the given polynomial to 0 and find the value of x. Whichever value x gets, that happens to be the 0 of the given polynomial. So we can very well understand looking at the different sums. X plus 5, for x plus 5, minus 5 is the 0 of the polynomial. When x polynomial is x minus 5, the value 5 is the 0 of the polynomial. These are the different sums, how you can find the 0 of the polynomial. How do we find the 0 of the polynomial? Just equate the polynomial to 0 and evaluate the value of the variable given in the polynomial.